Greetings, Moralis community. Phil here, your head of research at Moralis, and we are back with another developers live stream event. Today, I'm joined again by Ben over at Axelar. Ben, how are you doing? Welcome to the stage. I understand we're learning about stablecoins and taking those stablecoins multi-chain while maintaining some additional stablecoin features in the process. Am I right?
Yeah, hey, it's good to be back. Hey everyone. Yeah, it's exactly what we'll be doing, and I can get right into it if you want. But for those who don't know me, my name is Ben. I'm a developer advocate with the Axelar team, Interop Labs team. Been here for just over a year now, based out of Toronto, Canada, and yeah, it's great to be here again.
Amazing, amazing. Now, really quick for anybody who's watching this right now, hearing stable coins for the first time or just doesn't know that much about them. Stable coins are coins which are stable to a fiat currency or other asset which is outside of crypto. So you've got things like USDT, USDC, they're stable to dollars. So we can use them just like dollars on chain to buy Bitcoin, sell Bitcoin, Ethereum, other assets like that. But then when it comes to the multi-chain world, there's important things that we need to keep in mind when using these tokens multi-chain, and that's where Ben is going to show us all the tips and tricks that we need to know. I think we're ready to get into it, Ben. Did you want to share your slides to start with here?
Yeah, let's do it. I'll just share my screen.
Perfect.
I'll be flipping from the slides to code.
All right.
Alrighty. Share screen. All right, you can see?
Yes, perfect. I'm going to add that here. All right, there we are.
All right, so I'll get right to it. Lots to cover. And if you have any questions, just write in the comments section, and Phil cut me off at any moment if there's anything from your end that you want to ask. But let's get to it. So yeah, so as Phil said, we're today building multi-chain stablecoins powered by Axelar. And specifically, what we're going to be using is a feature that the Axelar team rolled out a number of months ago called Interchain Token Service, otherwise known as ITS. And ITS basically allows you to connect fungible, customizable, and secure tokens. So what does that mean? It means that you can use ITS to basically either deploy your own tokens via ITS. And these are kind of simple ERC20 tokens. You can deploy them very easily on any chain that is connected to Axelar. Or you can also deploy your own custom tokens with any special functionality that you want, and then wire those custom tokens up with ITS, which is what we'll be doing today. Right here is a screenshot from a really cool tool that I kind of want to share with you guys quickly just before we get into the actual technical demo. This is the actual ITS portal. So recall what I said before, ITS allows you to also wire up custom tokens and deploy tokens from ITS itself. So for anyone who is like maybe not technical or doesn't want to go about writing code, we have like a really easy to use front end, which can basically allow you to deploy your token on any different chain that you want to. Just popping back here to the slides. This is a screenshot I took from the front end earlier today. You can see I deployed a token here on Ethereum Sepolia, minted 1,000 of them, and then also registered this token on Blast and on Avalanche, and I can transfer this token just at the click of a button between Ethereum and Blast or Avalanche. I could register my ERC20 on any of these other blockchains as well. And it's as simple as just going through this flow, deploy a new interchain token, and then enter all the different parameters which it needs, and then deploy it on any chain that I want. So that's just a brief detour on the front end tool. I think it's really important for people to know about it, just to go play around with it if you're interested in any of this. But going back to what we're going to actually be doing today, bringing this back to the cross-chain stablecoins, what we're going to be building, it's actually several different contracts. And we're going to basically building out a custom token. So if you look here at the bottom left corner, we're going to be calling this the native token. And this token, it's going to be coming from, it's inspired by many conversations which I've had with different stablecoin providers in my experience here, just stuff that I know that teams have been looking to do with stablecoins. And that is why we're calling this native token. The idea is that we're going to have a token on a home chain. CeeLo in this example, but it could be any chain, and it could be more than one chain. But in this case, it's just going to be CeeLo, and it's going to have all these different features which we're going to build out together in this native token. Okay. Then on the flip side of that, we have what's called a semi-native token. And this will be a token which will be on a remote chain, in this case, Moonbeam. And it will be a kind of much lighter version of the native token which we deploy. It'll just have like simple minting and burning functionality, none of the extra fancy features that we'll be building on the native token. And this is inspired by real use case. If in some cases where there's like regulatory precautions or just any different caveats for why there's many different caveats for why teams might want to initially go with their complete native token on a certain blockchain. Rather, they start off with a semi-native and then eventually maybe upgrade to their native token further down the road. So we're going to be deploying both native tokens and semi-native tokens today on different chains, and using the interchain token service, ITS, to actually send transactions of these tokens between the two chains. Deploying the native token, we're going to have a token factory, which we're going to build out ourselves. And this will basically, as you might think, just deploy the native token, but it'll also be using Axelar general message passing, otherwise known as GMP, which we've done talks about in the past, to basically send a cross-chain message from one blockchain, CeeLo, to another blockchain, Moonbeam, to another contract, which we'll call deployer. It's kind of like the instance of the token factory on a remote chain, to basically deploy these semi-native token contracts. So the flow, one more time, we have a token factory, which can deploy your native token on your home chain. It can also send a GMP message to a deployer contract, which we'll write up, to deploy a semi-native token contract on a remote chain. And we'll be able to bridge these two native token and semi-native token contracts to each other via interchain token service. Any questions so far on any of this? If not, I will move on.
Very good so far. And also, I just wanted to mention, I see some comments in the chat about this. There is a tutorial where we talk about tokens which are non-stable coins and using ITS and even GMP with those tokens. That's a different tutorial. This one is focusing specifically on stable coins, but just know that that functionality is there if that's what you're looking for. Back to you, Ben, as we continue our demo today.
Yeah, just to build off that, that's kind of the beauty of interchain token services, that you can connect any custom token, any custom ERC20 that you wanted. So you can have something like a stable coin, but you can also have a whole range of different ERC20s that you can now have cross-chain functionality for by connecting it to ITS. So what is the token that we're going to be building today? Like I said, there's the kind of lighter semi-native token, which we'll go through, but then there's the native token, which we'll be working on. So some of the features which we'll build into that are the token is going to be an upgradable token. All the contracts will actually be upgradable today. We're going to have what I've called like transaction fee accrual for the community. And that's basically just a kind of wordy way of saying like a fee rate, which will be built into the token, and every transaction or every transfer that you send of the token, a small portion of that will be sent towards a community pool. And then holders of the token will be able to claim rewards from the community pool. And that reward will be in proportion to how many tokens you're holding. It's meant to be like a kind of incentive for holding the token, that you can earn rewards from this community pool. We'll also have a burn rate, which will burn a small percentage of your tokens that you transfer to make sure that inflation is kept under control for this token. And we'll be deploying this token via something called Create3, which is a service that the Axelar team has built, which allows you to deploy a contract. Doesn't have to be a token, could be any contract, with a specified salt that you pass in. And the idea is that you can now have a predictable address for your contract. Why does that matter for us? Well, we're going to be deploying this custom token on a number of different chains, and we want to make sure for the best user experience that token address will be at the same address across all the different chains that we're deploying on. So that's where Create3 comes in. And I believe that is it for the slides. Let's jump right into the code here and start building. If this font is too small, please call me out. I'll make it bigger. And yeah, let's get right to it. You'll notice that we have some built-in functionality already. I apologize. We could be here forever if we wrote it completely from scratch. So we're going to kind of build out the most critical parts together. So here we have our native token, which we'll be building out. We have we're inheriting from OpenZeppelin's ERC20 standards here. Most importantly, the ERC20 upgradable contract. So we'll be implementing a lot of stuff in conjunction with that. And I want to start right with our initialize function. Initialize, we're going through initialize rather than a constructor because this token is going to be upgradable. So right off the bat, if we look here, we're passing in two contracts. The first is our access control contract, which we will not be writing together. I wrote it up already before, but an access control is basically where you can manage different roles for the token. So for example, an admin role, a minter role, a blacklisted role, like a list of addresses you might not want to transfer to. This is also coming from OpenZeppelin. It's also upgradable. And we'll be using this to control like who cannot call and can call certain functionality in the token. So we need to pass that address in here. And then we pass in the address of ITS, the interchain token service. Remember, the kind of service which is going to be registering our token to provide this cross-chain functionality using Axelar. So we have to pass in the address for this token. The address is in our docs. It's just a smart contract that lives on any EVM chain that Axelar connects. Next, we want to initialize our token parameters. We call it USD token and just symbol USD. And we pass in our access control and ITS contracts addresses into storage. Okay, any questions so far on that before we dive a bit deeper?
Only comment I see so far is it looks like for people on mobile, if we could zoom in just a little bit, that might help.
Yes.
We're somewhat limited, guys, on how much we can zoom in, but hopefully that's a little better.
Is this better?
Yeah, looking good on my end. Let us know in the comments if you guys can read here as we go along.
Cool. Well, cut me off if it needs to be zoomed in a bit more, but I'll keep going. So remember, two of the key pieces of function that we want our token to have is this transaction fee redistribution and our burning for each transfer that we send. So how are we going to do this? Well, we're going to have to specify a burn rate and a transaction fee rate that will be kind of controlling what we're burning and taking away for the fee. So let's actually pass in these two numbers right in our initialize function. So let's set these in storage. S burn rate is going to the burn rate, and S transaction fee rate is the transaction fee rate. Do I have these written out? I do not. So let me write these in here. Public, what did I call this? S burn rate and UH6 public S transaction fee rate. Great. So now we are setting these two variables in storage. One other thing that I'll call out here, this modifier here, this initializer, for those not familiar with upgradable contracts, this will basically make this initialize function behave kind of like a constructor, where it can only be called once on deployment and then never really called again. Because it's an upgradable contract, we can't really use a constructor the way you traditionally would in a non-upgradable contract. Moving on to some of the deeper functionality here, we have our ability to pause and unpause tokens, again, restricted to whoever the admin is as registered in our access control contract that we showed before. We then have our minting and burning functionality. Again, basic ERC20 stuff. Mint, you cannot send this to a blacklisted address. And then the last function we have here is our update function. This is another OpenZeppelin function that we have kind of written out for us. And it will basically be called each time you're transferring your token from one address to another. And this will be super important as we want to build out some of our other like burning and transaction fee redistribution functionality. For now, before we dig into this, I want to implement these two functions, set burn rate and set transaction fee rate. This, as you might imagine, is for setting the burn rate and the transaction fee rate. Notice that we set it in the initialize function, which is kind of like our constructor. But if we ever want to override it, then we need some functionality to do that. So let's write that out really quickly here. New burn rate, when not paused, only the admin can do this. Set a new burn rate. And sorry, I'm going to run through this quick. What does this matter me for? This should be external. And set transaction fee rate same thing as before, set a new transaction fee rate, just like how we did with the burn rate. When not paused is admin TX fee rate. Cool. New TX fee rate. Great. The mint and burn function can remain as it is. I want to call this out briefly, that with the custom token, the really exciting thing with ITS is that we can build out whatever features we want with our token and still connect those to interchain token service and actually offer this cross-chain functionality for our token. Two functions that have to be there, though, are the mint and burn function. And that is because when we're actually sending our token from chain A to chain B, we're going to be calling these burn functions on this burn function on the source chain and this mint function on the destination chain to actually bridge that token. So these are two important functions to have. I'm keeping them open for now. Obviously, in production, you'd want to limit who can call this. You'd have to limit this to ITS's services, but I'll get into that a bit later. For now, I want to implement two of our critical features for our token. So remember, transaction fee accrual for the community and a burn rate. So we want to deduct a bit of the value that was transferred from party A to party B, first to be burnt, and second to go to the reward pool. So let's actually build that out. So we've passed in so far at the very beginning a burn rate and transaction fee rate, but we want to burn an actual amount of tokens, not just a rate, right? So we basically have to calculate, hey, based on the rate that we have passed in for the token, what is the actual amount that we'll be burning? And that's very simple. We have to take the value, which is the amount of tokens that are being transferred from a sender to a recipient, and we multiply that by the burn rate, and we'll just be dividing it by 1 to the power of 18 because this token will have 18 decimal points. Yeah, and we'll do the same thing for the fee rate divided by 1 to the power of 18. And now that we have the actual burn amount and the fee amount, we can actually calculate how many tokens our end receiver should be receiving after the burning and the fee. So we have amount to send is the value, what I'm actually sending, subtracted by the fee and the burn amount. And a couple checks here. If the burn amount is greater than 0, which it will be, then we want to call the burn function, which is a function given to us by OpenZeppelin's ERC20 upgradable contract, which we're inheriting from. We want to burn from the sender. From, and how much are we burning? We're burning the burn amount that we calculated on line 119. Then we want to have one more check here to make sure that everything has been calculated correctly. So if the amount to send plus the burn amount plus the fee is not equal to the value, then revert because we have an invalid send amount. This should hopefully never happen, but just in case, we have this check right here. Now, the next thing we want to do is we've burnt the correct amount of tokens with the burn amount. Now we want to actually send whatever this fee amount is to a reward pool, which holders of the token will be able to claim. So let's create use a variable here called reward pool, and it will be incremented every single time this update function is called with the fee. This is giving me an error because I don't think I actually defined this variable up here. So let's do that. Great. So now we're incrementing the reward pool each time a transfer is sent. Next, we want to, sorry, I should have moved this down, call this update function. This is OpenZeppelin's function will actually be now updating the token to be sent from a sender to a recipient with the value that was sent. Cool, and this should be amount to send, not value. Emit, reward added, fee. So basically, the last thing we're going to be doing here now is emitting a reward for every time a transfer was sent to basically say, hey, in this reward pool, a new tiny reward amount was added, and that's what this event will emit for us. And I believe I already defined this up top. Yes, I did. Cool. Next, so at this point, once we send a ERC send a transfer on this token, we'll be burning an amount based on the burn rate. We'll be deducting a fee based on the transaction fee rate and sending that fee to the reward pool. The last thing we have to do here for this token is actually have some claiming rewards functionality for a token holder to claim the rewards that they have proportionally to the amount of tokens that they're holding. So let's write that out very quickly here. This will be an external function which anyone can call, and we have to calculate, well, how much reward are you able to claim from this token? So we'll have actually a helper function here called calculate rewards. So let me write that out first. This will be an internal function. And basically, let's check if the total supply is equal to 0, then we return 0 because there's no rewards if there's no tokens in circulation. But assuming that is not the case, we want to get a reward proportional to you as the holder. So we check the entire reward pool. We balance it. We check the balance of the message sender of this transaction, so the account. And we divide it by the total supply of all tokens in circulation. And this will be the amount of a reward which you as a token holder receive proportional to how many tokens you're holding. So let's call this function here, calculate rewards. Will be the rewards for the message sender, whoever is calling this transaction. This should be, balance of. Cool. Next thing we want to do is deduct an amount from the reward pool, which basically means like, okay, I've claimed this reward amount, now deduct it from the reward pool. We then want to mint tokens in proportion for how many tokens you just got as a reward. So now we're actually sending those tokens from the reward pool to you and deducting it from the reward pool supply. What have I done wrong here? Oh, whoops, I forgot to set returns. Returns.
No, I did have a quick question for you, Ben.
Yes.
And maybe this is just anecdotal, but it's something that popped into my head, so hopefully it benefits others as well. Why do we need the statement if the amount is 0, return 0? Isn't that going to happen anyway? By virtue of
yeah. This was just the
okay.
Yeah, it's probably don't need it. It was just an extra check here, just in case. But yeah, it would probably be fine without it as well.
Oh, perfect. I just want to make sure I was understanding correctly. So that confirms what I was thinking. Please continue.
Yeah. The last thing we want to do for this claim rewards function is once you've claimed a reward as a token holder, let's just emit an event saying that a reward was claimed and who claimed or who received it, the message sender. And how much did that message sender receive? Well, the reward amount that we calculated here in the calculate rewards. And that should be it for this token. Trying to keep it relatively simple using a lot of features which we've seen in the past stablecoins have. We're not going to worry about like depositing and withdrawing collateral. I want to spend more time focusing on the cross-chain component of this, actually sending this token from chain A to chain B. But let's review it quickly one more time and make sure I didn't forget anything. We deploy this token, this upgradable token, by calling the initialize function. We pass in the access control, which controls like different roles and who can call what function. We pass the address of ITS, which we'll be using for the bridging component of this. We pass in the burn rate and the transaction fee rate. We initialize our ERC20 contracts that we're inheriting from with the name and the symbol. We have our pausing and unpausing functionality. We have the ability to update our burn rate and our transaction fee rate, which only the admin can do. We have the ability to mint and burn tokens. We have the ability to claim rewards in proportion to how many tokens you're holding. Helper function here to calculate the amount of rewards you're getting. And then here in the update function, which is called every single time a token is transferred from one party to the other party, we want to actually burn an amount in relation to the burn rate and deduct a fee from the sent amount relative to the transaction fee rate. There's one more thing I'm just realizing now I forgot to do, is that we only want this burning and transaction fee rate deduction to take place when we're sending from like me to Phil or from party A to party B. We don't want this to actually execute when we're minting fresh new tokens. So it's a very easy fix for this. We basically check, hey, if the from address is address 0, then we're minting. And if we are minting, we can just call this update function to actually send the token, and we will actually return so that we don't run any of this other functionality. And this time we're not calling amount to send because we're not deducting fee or burn amount from anything. We're just going to send the complete value on its own. And that is basically it for this token. So if you recall in our slides, we have the native token. We also have the semi-native token. For time's sake, I'm not going to write this one out myself, but I'll go through it very quickly. It's a kind of lighter version of the token we just built. We pass in the ITS address. We pass in ITS token ID. We will get to that later. We have our minting and burning functionality, just as we did before. We have our interchain transfer, which is like our bridging functionality, which we could and should add this to our native token as well, this interchain transfer. And then we have, as you can see, a much kind of simpler version of our update function, basically without any of the burning or transaction fee stuff that we were doing before in the native token. So what we have to do next is start building out this token factory, which will actually use to deploy our native token, as well as send a message to deploy the semi-native token on a remote chain. So let's pull this up. Cool. So yeah, there's some stuff written out here from before. I'm going to start again with the initialize function. We'll come to the stuff in storage and the modifiers a bit later. So what do we pass in? We pass in our interchain token service address, which we'll be using for bridging. We pass in two very critical functions called the Axelar gas service and the Axelar gateway contract. These are contracts which we'll be interacting with when we're actually sending our cross-chain messages when we're deploying or we're sending a message to deploy the semi-native token on the remote chain. I'll come back to these in a lot more detail soon. We, again, pass in an access control to handle the roles, and we pass in an instance of our deployer contract, which is this contract right here. Our token factory will need to know about it. And we'll be writing out this deployer contract ourselves after the token factory. But for now, to save us some effort, we pass it in just in the initialize function and put these all in storage here. Notice on line 81, we also have a salt for the ITS token. This giant kind of scary hex thing just represents the number 1, 2, 3, 4, 5. We'll be using this when we're actually connecting our ERC20, our native token that we just built out to ITS. We'll need a salt for that. You'll see that in a bit. Cool. So let's begin to write out this function called deploy home native. As the name suggests, what we're going to be doing is, well, deploying this native token that we just wrote to the blockchain that we're on. So if this token factory is going to be deployed on Celo, we'll be deploying this native token on Celo. And we'll call Celo like our home chain for now. Why Celo, you may ask? It has very fast finality time, so it'll be good when we're bridging, and a working faucet, which is hard to come by nowadays. So I've been using that a lot. Same goes for Moonbeam. That's where kind of be going between Celo and Moonbeam. So
Ben, I just wanted to clarify there. Yeah. So really, we could set up our token factory on any Axelar compatible chain, and it's just so if, for example, I'm running a business project and I have all of my smart contracts on a particular chain, all of my ETH there for gas as an example, I could certainly just use the one that I'm already using and set it up there. Is there anything that I should be aware of if I'm using a chain different than Celo, or is it just the same no matter what?
No, as long as the ITS contract is deployed there. So I'll actually pull this up right now in our documentation. These are all the different EVM blockchains that Axelar is live on. You can see all these different chains here that you can go just the way I'm doing with Celo right now. And you can see as long as the interchain token service exists there, and it should be at this same address across all these different blockchains, you should be good to go on those chains. I like CeeLo for testing just because it's a very fast blockchain, and like I said before, the working faucet is nice as well.
CeeLo is a popular blockchain for stablecoin development as well. Just a little DeFi anecdote there for any of you DeFiers who are tuning in.
Yeah, okay. So I'll start writing up this function now to deploy an instance of our native token on chain. So first thing we want to do is we have, so again, this is going to be only deploying for the home chain. So just for CeeLo. So we have a storage variable called native token, which will basically be set as the address of this native token once it's deployed. Which means that if we have yet to deploy it, it should be at address 0. If it is not at address 0, that means the token is already deployed and we can revert with an error. So that's what this if statement is doing. Next, I need to grab 2 more salts right here. Again, I apologize for the kind of scary looking salts. It's just number 1, 2, 3 and 1, 2, 3, 4. We'll be using these momentarily when we're deploying the native token, and you'll see why in a second. Actually, we'll use the first one right now. So remember what I said before. This token, in addition to the burn rate and the transaction fee redistribution, it's going to be an upgradable token. So my very brief crash course on upgradable contracts, I'm assuming most of you are familiar with it, but on a high level, we have 2 contracts. We have a proxy contract and an implementation contract. The proxy contract will be basically what you as the user interact with. It'll be storing all the user behavior from the user's interaction. So for example, your balance of your ERC on your ERC20 contract will be stored on your proxy. Your implementation will actually be everything we just wrote out here. And basically the way it works is you will interact with the proxy contract and the proxy will delegate call into the implementation contract. So everything in the logic in the implementation contract will be stored on your proxy contract. And the way we get upgradability from this is that all we have to do is say, hey, proxy, instead of pointing to this V1 implementation with all this native token code that we wrote, can you actually now point to V2 with a new native token that we've written out? And there's some caveats there, but that's kind of the simplest form that I can put it. We have a proxy and an implementation. The proxy points to the implementation, and we get upgradability by telling the proxy to point to a new implementation with presumably more advanced stuff built into it. So I hope that's clear. And what does that mean for us? It means that we have to deploy, well, 2 contracts. We have to deploy an implementation of our native token and a proxy to actually point to that implementation. So let's start by pointing to the implementation. And we're going to be using create3. Create3 is a contract, like I said before, which Axelar makes available for us. We're going to be inheriting from it. And it basically allows you to deploy a contract at a predictable address. What does that mean? It means that we can have our token at the same address across X number of different chains. So what we're going to be passing into create3 is our creation code and our salt. So it is the creation code of the native token, which we have just written up. .creation code, and we're going to be passing in the salt from line 97. So that this way our implementation will be at a predictable address. And then all we have to do is basically go, hey, if the new token implementation is for whatever reason at address 0 still, then we should revert because something went wrong with the implementation. It should not be at address 0 anymore. So that's one contract done. That was very quick. We now have our implementation live on CeeLo. Next, we want to actually deploy the proxy, which will be pointing to the implementation. And there's this one's a bit more going on here. So actually, before I write this, let's scroll down to the bottom here, with this function here, this get encoded creation code native. And all we're doing here is, let me close this, is we're going to be getting this creation code that we got here out of the box very easily for our native token. We're going to need to be getting this for our proxy. So what are we doing here? We're first going to be encoding our init data because in addition to deploying the proxy, we're also going to have to be telling that proxy, hey, initialize this data that we want. And what data do we want? We want to pass in these 4 parameters here. Remember, we pass in the access control, the ITS address, the burn rate, and the transaction fee rate immediately as soon as the token is deployed. I'm actually going to pull this up side by side to make it easier. And that's what we're doing here on line 125. We basically grab our selector for our initialize function, which is the guy here on line 60. And then we're going to be passing in 4 values: the address of the access control, the address of the ITS variable, the UN256 burn rate, and the UN256 transaction fee rate, which corresponds to what we're passing in here in the initialize function of our token. So then once we have our init data here in line 125, we want to actually encode all of this with the creation code of our proxy contract. I'll get to this in a second. And we encode the implementation address of what is our proxy pointing to. That's the implementation which we just deployed up here on line 100, as well as the proxy admin, which is like a contract that can actually upgrade our token. We don't want just anyone to be able to upgrade the token, right? As well as the init data, which we just created here on line 125. I glossed over this. What is this? This is the creation code of our proxy itself. The proxy itself is a contract here called Transparent Upgradable Proxy. It's coming straight from our friends at OpenZeppelin who've written this out for us. And this is basically the logic of the proxy contract, which our users will be interacting with. And all what it really has to do is just know, hey, every call we get, point to the implementation contract. Do that guy's logic, as well as upgrade when the time has come to upgrade. And once we do all of this stuff here, we return our proxy creation code on line 127, which we can now go back up to our deploy home native, create a variable called proxy creation code, and we can make a call to get encoded creation code native, which is this function here that we just went through, and then pass in the parameters that it wants. So it wants, hey, who is the proxy admin? Let's just make it the message sender, me for now. And this is safe because we have an only admin modifier. So only the admin can be the message sender anyway. We then want to pass in the implementation address that the proxy will be pointing to. What is this? This is the guy from line 100 that we deployed a few minutes ago. We pass in the burn rate, and we pass in the transaction fee rate. And at this point, once we call deploy home native, we have our proxy creation code that we want to deploy. So let's do exactly what we just did on line 100 with the implementation. Instead, let's do it with the proxy for now. So we're going to use our new token proxy variable, which we have defined here. It'll be returned in this function call. And just as we did before, we're going to call create3. Instead of the native token creation code, we're going to pass in the proxy creation code, which we just got in the line above. And we're going to be passing in our salt. Again, the salt will be used to get a predictable address with create3. Create3 needs a deploy salt.
Now, when we're assigning our salt in order to generate a predictable address across all of the chains that we're using, do we want to, because I see here you're using examples 1, 2, 3, 4. I assume we would want to use a more unique number than that for security's sake. Just wanted to clarify that. Yeah.
Yeah, I did it here just for simplicity's sake. Normally you'd want to generate it in a better way than I'm doing right here, but I just wanted to have this in the kind of clearest, simplest way. The important thing is that you don't lose your salt, because if I don't know what the salt is that I use to deploy this address on CeLo, then I won't be able to get the same address on Moonbeam or on any other chain, right? Because the salt needs to be the same to actually get the same contract address. So it's important you don't lose that. Great. Now, once we've deployed our proxy, let's again make sure that it deployed correctly. So let's ensure that it is not address 0. If it is, then we revert with deployment failed. And then we can save this new token proxy into our storage. Great. So at this point, once we call this function, we will deploy an upgradable version of our native token that we just wrote up before and save it in storage. Now, this is not all we want to do, right? Remember, the point is we don't want to just deploy a token. We want to deploy it and actually bridge it from one blockchain to the other blockchain. And for that, we have to use our beautiful friend Interchain Token Service to actually do this. So ITS is a contract with lots of functionality. This is our interface for ITS. We're not going to obviously go through all of it now, but the function which we're going to be interacting with, if I could find it, is called Deploy Token Manager. There it is. This contract will basically deploy what's called, well, as the name suggests, a token manager for your contract. So when you're connecting your token with ITS, you can think of it this way. You have your token, which we have just deployed, and then ITS deploys a token manager for you, which is a separate contract, which will basically be facilitating your connection between your token and ITS, and by extension Axelar. So to actually connect your token to ITS, you have to deploy this token manager. So let's do that together right now. And more about the token manager in a minute. But let's actually start writing this out. So we're going to call our ITS variable, which we have set in storage. Recall in the initializer right here on line 75. So we have access to that. And then we're going to call the function you see on the right, deploy token manager. And you can see it takes several different parameters. The first is the salt. So we're going to be using this salt that we passed in at the very beginning. We're just going to read from storage for now. And we're going to have to be using the same salt on every other chain that we want to connect this contract to. And you'll see why in a second. The next thing we want to do is pass in the address of the destination chain. Like, hey, where is this token manager? Where are we deploying it? We can just pass in an empty string for now because we're just deploying it on CeLo itself. If we were deploying it, making a cross-chain call to deploy it on Moonbeam, we would specify Moonbeam here or Ethereum. But for now, it can just be an empty string. Next is the token manager type. So remember what I said before, that when you're connecting your token to ITS, you have a buddy for your token, the token manager. And there's different types of token manager, and these pertain to the different ways which you can bridge your token. I believe there's like 4 or 5. The main two we'll be discussing for today are the lock-unlock token manager type, that's one, and the mint-burn token manager type. So for this case, we're going to be doing the lock-unlock token manager. So I go I token manager type, and I'll explain what the difference is in a second. Token manager type, lock, unlock. So let's just finish up this deployment. I'll go back to the token manager type. The next parameter that we have, the fourth one here, is params. The name is a bit unclear. What this is asking for is an encoding of the operator of your token. So basically, who can have like certain admin roles in your token manager, and I'll explain an example of what those admin roles are in a second. So let's just have it as me for now. Message sender, it has to be of type bytes. 2 bytes is coming from a library that we defined above. So that's the operator. And then the second parameter, which we have to encode here, is, well, the address of the token itself that we're connecting to ITS. What is the address of our token? That is just going to be this new token proxy address that we just deployed. And the gas value will be 0 because we are not actually making a cross-chain call here. I think I'm missing something here. Let's see, what did I miss here? Token manager type, lock, unlock, ABI encode, message sender, 2 bytes. Oh, this should be, sorry, here. Okay, now we're happy. Just going back to what I discussed before, the token manager type, lock, unlock. This is basically a type that you want to use in cases where you have like a home chain and you want to have like let's say like a wrapped version of your token on a number of different chains. So for the home chain, you have lock, unlock. For the other chains that you want to deploy on where there is no home chain, you can just have like mint burn, which will allow you to basically burn on source chain, mint on destination chain. Whereas here you lock on the source chain and unlock once the transaction is bridged back from a different chain. And now once we call this function, we should actually have a connected token to ITS. One thing I want to do is actually return the token ID. See, that's being returned here. This is like the unique interchain token ID, which ITS will have for your connected token across all different chains. So on CeLo, Moonbeam, Ethereum, all the different instances of your token which you've connected will be connected to each other via this interchain token ID. And that's why the salt, among other things, is very important here, because that's the unique identifier which you use to generate your token ID. That, as well as the address that's connecting the token. Sweet. Now that we have our interchain token ID, let's close out this function just by emitting an event called native token deployed. So we will emit the address of the token that we just deployed, as well as the interchain token ID of the token that we deployed. And that is it for this function. Once we call this, we will deploy an upgradable version of our native token and connect it to ITS and return the interchain token ID and emit this event, which represents our new token that we deployed, the address of it, and the interchain token ID. Any questions on this function? If not, I will move on. I understand, I apologize, this is a lot going on here. But quickest way to summarize it is deploy your token connected to ITS. Now, the next function we want to do here is actually deploy remote semi-native token. Recall on this graph, we've so far done just about everything here. We've built out our token factory. We built out a function which can deploy a native token on the same chain that our token factory lives. But what if we actually now want to, with this token factory, send a cross-chain message and actually deploy a token on a different blockchain? That's what we're going to do here in this deploy remote semi-native token function. And I know these function names are mouthfuls, but I hope they're accurate in describing what they do. So notice here we have just one parameter, the destination chain. So we're basically saying like, hey, which chain do we want to actually deploy this on? Cool. So first thing we want to do is, just like in the last function, check like, hey, do we have a semi-native token deployed on that destination chain that we're going to deploy on already? We want to make sure that we do not have a token already deployed there. And then also, do we have a native token that exists? If we don't have a native token that exists, then there's no point in deploying a semi-native token, which can't be bridged back to a native token. So we're going to revert with this token already deployed error message, which I know is more so just for this case. I'll keep it this way just for simplicity's sake. The next thing we're going to want to do is generate our token ID. Remember, this deploy token manager function, when we're actually wiring up our token to ITS, returns a token ID. So, I want to actually compute our token ID here before we send our GMP message from Silo to Moonbeam. And you'll see why in a bit. But for now, we're going to actually generate the token ID ourselves. And we do that by hashing out a hash of the string interchain ITS interchain token ID with the address of the deployer, which is this contract, and the salt, which we're using to deploy this token. All this hashing returns our computed token ID, which should be the same, by the way, as this token ID. It's just the difference is we're computing it ourselves now rather than ITS doing it for us. Now that we have our token ID, let's actually construct the message that we're going to be sending from Silo to Moonbeam. So GMP messages are, like I said before, messages going from chain A to chain B. It can be something as simple as hello world from Silo. Or it can be something as kind of put together as we're about to do right now. So GMP messages have to be of type bytes, which is why we're encoding it. We want to pass in the computed token ID as our GMP message, but not just that. We also want to pass in the creation code of our semi-native token, which we'll be deploying, as well as the initializer for the semi-native token. All this put together will be our GMP message that we're sending. So you can see how powerful this is. Like, we're passing in a lot of stuff here. These three parameters, especially this creation code, is a lot of data that we're passing in as a transaction from one chain to the other. We can, of course, have just imported this ourselves on our instance of this token factory, which will also live on on our destination chain. But I really want to drive home how powerful Axelar GMP is to send these tokens from one chain to the other, or to send, messages from one chain to the other. It can really be as flexible as you want. Now that we have our message, which is going to be sent from CeeLo to Moonbeam, how do we actually send it? So there are two critical contracts which we use to send a GMP message. And now I'm keeping my promise and coming back to these two contracts, which I promised we'd be discussing a bit deeper in the initialize function here. That is the gas service and the gateway. The gas service is basically a helper contract, which will be used to actually handle the payment of the entire cross-chain transaction. So let's say I'm going from Ethereum to BNB. I don't want to have to worry about holding BNB and Ether and AXL to pay the Axelar chain, which is facilitating the transaction. All I want to do is pay for the entire transaction in Ether. And that's what the gas service allows us to do. So we call this pay native gas for contract call. Again, a bit of a mouthful of a function, but accurately named. We pass in this message value, which we're using to pay for the transaction on the source and the destination chain. And then this requires a number of different parameters. So I'm going to pull this up for you guys so you can see it. So pay native gas for contract call. So this function here, which we're implementing. And it takes in the sender. Who is the sender? Well, it is me, or not me, but the address of this contract. What is the destination chain that we're going to? That is the parameter that we are passing in here. What is the destination address that we're going to on that destination chain? It is going to be our deployer contract. Remember, in our diagram, this deployer contract is going to be receiving the message on Moonbeam from our token factory and deploying the chain. So that's the destination address that we're sending this GMP message to. So we pass it in right here. What is the payload? Like, what is the message that we're sending? Well, it is what we just constructed on line 93. So I'm just going to copy and paste GMP payload. And what is the refund address? So what if my message value, sorry, I lost my spot. What if the message value that I sent is way too much? Like, what if I'm sending one full Ether to cover this transaction? Well, you basically get refunded the difference of whatever it is the message value that you sent is if you paid way too much gas. Nice. So at this point, when we call this function, we'll be paying for our entire cross-chain transaction. We then want to actually send that cross-chain transaction. So that's where the gateway comes in. So we have our gateway, which we can call a function called call contract, and it takes in similar functionality to our to what we just passed into the gas service. It needs to know what is the destination chain that we're going to, what is the address of that destination chain that we're going to, and what is the payload, the message that we're sending. And that is it. Let me close this so it's a bit cleaner. Once we call this, we will successfully send a message from CeeLo to Moonbeam to actually deploy our semi-native token on Moonbeam, all by just clicking this one function here back on CeeLo. We do this by paying for the entire cost of our cross-chain transaction with the gas service, and we actually fire this off by calling the function call contract on our gateway. Remember, the gateway and gas service were passed in here in our initialize function. We specify the chain that we're going to, the address on that chain that we're going to, and the message that is being sent, which is this large GMP payload message right here.
Every time we do these live streams,
yeah.
Oh, sorry to interrupt, but I say every time we do these live streams and we see it finally come together here, it's really exciting. And let me maybe paint a little bit of a picture for that for any DeFi users who are watching right now, maybe not so familiar with the developer environment. This right here, what we're looking at is the solution to an extremely common question by blockchain developers. If I have all of my resources and all of my effort on one chain, but I want to take a token and deploy it somewhere else, why can't I just do that? And here we can see the answer is you can. You can have all of your assets on a particular chain, and using the gas service, using the interchain token service, using general message passing, you can literally mint a token on another chain without ever setting up a gas holding wallet over there. And that's groundbreaking. And that's very exciting. So just wanted to comment there, kind of break it down a little bit for anybody who was missing that connection.
Yeah, it gets me excited even just hearing you repeat it. So it really is an amazing thing the team has built here. We're not done yet though, because once you call this function, like I just said, we send the GMP message to the destination chain at that address. But what do we actually do once we get there? We have to implement some kind of receiving functionality to handle that transaction once it comes in. And I know we're getting low on time, so I'll try to go through this last part quickly. So we have our next and final contract that we'll be writing up, which is the deployer contract. And this is basically kind of like an instance of our token factory that lives on any of these non-home chains that we have. So any chain that is not Celo will be using this deployer, and that'll be interacting with the token factory. It's very, very similar to the token factory itself. And you can see in the initializer, taking in ITS again, access control, and our gateway. Sure, I understand. Oh, sorry, Siri woke up. So yeah, we've taken ITS, access control, and our gateway. Set the same salt for our ITS token ID, this 1, 2, 3, 4, 5 here, because we're going to want to be connecting our semi-native token, which we're deploying on Moonbeam, back to our native token that we deployed on Celo. So this token should be connected to this token. A way we do this, or a key part of how we do this, is by using the same salt when we're deploying both of these tokens. So let's pick up from where we left off. We call this deployer mode semi-native. This fires off this call contract. It goes from Celo to the Axelar chain to Moonbeam. We then have this execute function, which is going to basically be receiving this call on Moonbeam now, on our destination chain. Okay, so you see we have a number of parameters that get called automatically by an Axelar relayer, and we'll be making use of these parameters. The first thing we want to do is run this call here for validate contract call. This is basically a security check to make sure that even though this execute function is an external function call, which can technically be called by anyone, this validate contract call, which is defined in our gateway, will basically ensure that, hey, the data that's being passed in here, has it actually been confirmed by the Axelar network? Like, how do we know that this call is for real, that this actually happened on Celo, and this is what's being passed in? That's what this validate contract call does. We don't always have to define this ourselves. If we were to do a non-upgradable contract, we can basically inherit this execute function from a contract called Axelar executable, which implements this for us. But we're going to actually be writing this up ourselves this time, which is why we have to call this ourselves. Now that we've ensured that the call is secure, we want to take this GMP message that we sent here on line 103, which we defined on line 93, and actually decode it on our destination chain. So let's actually do that first. ABI decode the payload, which is one of our parameters that we get in here. And let's actually decode it from this kind of useless bytes type to our original data types that we passed in. So our bytes 32, bytes, and bytes 4, which correspond to the bytes of the computed, the bytes 32 of the computed token ID, the bytes of the creation code, and the bytes 4 of the semi-native token initialize selector. And let's destructure this here. Bytes 32 computed token ID, bytes memory semi-native token bytecode, and bytes 4 semi-native token selector. Sorry, bytes memory. What did I miss here? AVI decode payload. This should be a comma. AVI decode payload, and this should be okay. Sweet. So now we've successfully retrieved our message that we sent from Celo, and now we have access to all this fun stuff here on Moonbeam that we can use to deploy the token. So first thing we want to do is let's grab in our 2 salts, just as we did in our deploy home native function, to make sure that we have the same addresses being deployed here. And then let's basically do exactly what we just did here in the deploy home native, but we'll do it now on a different blockchain. So let's write this out ourselves. So first, because it's an upgradable contract, we want to deploy the implementation with create 3. We pass in the semi-native token bytecode, which we just received here in our GMP message. And then we want to pass in the same salt as we did on our Celo blockchain to make sure that the implementation is the same address. We then want to make sure, hey, did this deployment actually go through, or is it still at address 0? If it is still at address 0, we will revert with deployment failed, right? So this should all look very familiar. We're doing exactly on our destination chain what we did here on our home chain. We're just deploying our implementation for not our native token this time, rather our semi-native token. Remember, which we passed in here, semi-native token creation code from our source chain. We sent it as a message, received it on the destination chain, and we're now deploying it here on Moonbeam. Next thing we want to do is, in addition to deploying the implementation, we have to deploy our proxy. Because remember, it's an upgradable contract. So we'll call get encoded creation code semi-native this time, which is defined here. It's basically exactly as we did before. So I'm not going to go through the whole explanation again. But you want to pass in the proxy admin, which is the address of the deployer, the new token implementation, the computed token ID, and the semi-native token selector. So now, at this point, we will have, let me just put the check in, creation code proxy. We got the creation code. I forgot to actually deploy it. So we go new token, not implementation, rather proxy. And then we do the same thing as before. Create 3, creation code proxy, and the salt of the proxy to make sure that we have the same address for the proxy here as we did on Silo. And then we go, hey, if the new token proxy is address 0, then deployment failed. But if it's not address 0, then our deployment succeeded. So now we will have called this function, deploy remote semi-native token, send the cross-chain transaction with this GMP message, receive that message right here, and deploy our implementation and our proxy. And now we have 2 tokens deployed on 2 different chains at the same address, and they're both upgradable. The last thing we want to do is wire it up to ITS so we can actually bridge these tokens between each other. So we do it just as we did before. We called deploy token manager. We're called just as we did here. We're going to be doing basically the exact same thing. We're going to pass in the same. In fact, I'm actually just going to copy and paste it just to prove my point on how similar it is to deploy the token manager. We pass in the same salt. We don't need a destination address again. Why? Because remember, this execute is happening on Moonbeam. So we're not actually sending a cross-chain message. We have already sent a cross-chain message. The only difference is that unlike before, where we were on our home chain, I now have a different token manager type of mid burn. So on Moonbeam, once we're bridging out of Moonbeam, we're just going to burn the token completely. But on Silo, we're going to actually be locking it and unlocking it once we get bridged back. And then we have the same parameters. Our message sender will be the what's it called? The operator, and our new token proxy will be the address of the token. And we can just set this to 0 here. And that's it. Now we will have our token deployed at Moonbeam and registered with ITS. The very last thing I want to do here is actually, well, 2 things. First, I want to actually send a call back to our source chain, which will basically be our source chain as the destination address and our source address. And I'll explain this momentarily. Sorry, I know we're low on time. We're just about done here. So just as we sent a call from our cross-chain call with our call contract from Silo to Moonbeam, so we sent this call here, we get hit in the execute function here on the deployer contract. We do all this stuff that we just did, which was deploy the token and wire it up to ITS. Then we want to send it back to Silo. What do we want to send? We're not sending a big message this time. We're just sending the address of our new token proxy back to Silo so that our token factory and our home chain can actually track the address of our newly deployed token. Sorry. Now, this should be the exact same address, right? Because we used create 3. So what we have to do is just call execute here, just as we did here when we were handling our cross-chain message. Now when we're handling our cross-chain message on the callback, we call validate contract call again, and then we just decode our message that was sent into an address and store it in this mapping. So now when I call, hey, token factory, do we have any tokens deployed on Moonbeam? It will know that, yes, you do, and here's the address, all by calling this mapping. So in one click, we send a two-way transaction from CeeLo to Moonbeam and back from Moonbeam to CeeLo, all in one click. It's really, really powerful stuff here. And then the final thing we will do is actually have the upgrade functionality. Remember, the whole point is like these tokens are also upgradable. So how do we do this? Well, remember, upgradable contracts. It's a proxy, points to the implementation. So we have our new token implementation, which we will deploy right here. So let's call it type semi-native token v2 creation code. And we'll pass in just a random salt here. I don't really care what the address of this new implementation is. The only difference between type semi-native token v2 and type semi-native token, if anyone's curious, is just that this semi-native token v2 will have this is v2 function here, which we can see when we're testing it. So we deploy this new implementation. Now it's out there live on chain. And all we have to do now is, well, first make sure that's deployed correctly. So if the implementation address is 0, something went wrong, revert with deployment failed, as we always do. Then failed, whoops, deployment failed. But if it worked, then we have to tell our proxy, we have to make this call via the proxy admin, to, hey, tell our token proxy to now point to a new implementation. And what is the address of the new implementation? Well, it's the guy on line 102 that we just deployed. And then we're not passing in any data here. So once this is called, the proxy admin will say, tell our token proxy, don't listen to native token v1 anymore. Listen to native token v2, or point to native token v2 for all your future transactions. And we can deploy it for native token v3, v4, however we want. And that, for real now, is it. We are out of time to test this, but I figured we would be. So, by the way, any questions about any of this before we wrap up here? And I'll show you the tests.
Well, don't see a lot of questions in the chat. One person's asking, is it safe to use? And as much as I've worked with you guys, I would say that Axelar is one of the most, if not the most, developed solution for doing these types of cross-chain functions. There aren't a whole lot of other options out there, guys, but there's a reason why Moralis and Axelar work together on this kind of stuff, because when it comes to the way that Axelar goes about building these solutions, combined with the multi-chain data services that Moralis provides, you're able to take this start to finish and put in any kind of advanced functions that you're looking for. So is it safe? A lot of times that's up to you, depending on what you're looking to build and how you want it to work. But you are equipped with the right tools. I can say that for sure. Ben, did you want to add anything there?
Yeah, I kind of glossed over it for time's sake, but when you're doing these cross-chain transactions, in this case from CeeLo to Moonbeam, this is being facilitated by the Axelar network itself. And the Axelar network is an actual blockchain. It's maintained by 75 validators who are actually coming to consensus about each cross-chain message that was sent. And this is, tremendous improvement from like, more centralized multi-sig approach, which many interoperability solutions have, gone with in the past. This is an actual blockchain running proof of stake. It's a Cosmos chain, which is facilitating and securing like all of these cross-chain transactions. Between these two chains. Obviously, it's only as safe as the way when you use Axelar, you have to be safe with the way you build your contracts. But in terms of the Axelar network itself, it's the safest interoperability solution out there. It's been audited over 45 times. ITS itself also, the service that we're using here to actually facilitate these interchain transfers also has been audited many times. It's all open source. And if they want to see this stuff on the Block Explorer, I know we're low on time. Yeah, so I'm going to show that right now.
Yeah, go ahead.
So, unfortunately, not that much time to test it. So I will walk you through this test that I made. I know this is overwhelming, but we'll break this down. So what we did here, and let's look at the top terminal for now. Can you guys see, or is this too small?
I think this is good. If you can, maybe just a little larger would be better.
Here we go.
Oh, there we go. Perfect.
Okay, so the top terminal, we deployed our factory contract on Moonbeam, or Moonbase, I guess is their testnet. So we deployed the deployer contract on Moonbeam as well as on Silo. So this gave us our address of our deployer, 0xAD51, and our address of our factory on Silo. It's the same address, AD51, because remember, we just create 3. Pretty cool to get the same address. Next thing we did was actually call right here the deploy home native function. Remember, that was the first function that we did on Silo. So this guy right here, deploy home native, where we deployed our native token and connected it to ITS. Okay, so we ran that. This worked fine. We then were able to actually see the address. Don't worry about any of this. We were able to actually see the address of the token which we deployed. We then run this next function here, deploy remote semi-native. This is the final function that we worked on, where we actually sent that cross-chain GMP message from chain A to chain B. And the CLI might be a bit confusing, so let's just jump right to the Explorer. You can see this taking place right here. Let me make it a bit bigger. So once I called deploy remote semi-native token, it went from Silo to Moonbase, executed there. If I actually scroll down, I can see the step-by-step of these transactions on the native block explorers themselves. So I can, for example, for this sent, I can click on it and it takes me right to the Silo Explorer. For executed, I can see the execution taking place right on Moonbeam. Remember, execution is what we wrote out in this execute function here, which is where we deploy our semi-native token and wire it up to ITS. We then see the callback taking place because remember, we made another call right here on line 97 in our execute, which is why we have like this two-way call from Silo to Moonbase and Moonbase back to Silo all in one click. So that deployed our token on both on Silo and on Moonbase. And then this next call here was our interchain transfer, where we actually sent tokens which we minted to our own balance. We then sent those tokens from Silo to Moonbase, and we can see that taking place right here. I show it in the terminal, but it's not as clear when you're just looking at it. But you can see I called balance of here, and it was 0, and then I called it a few moments later, and the balance was 1, 2, 3, 4, 5, 6, which was the amount that I actually bridged over from Silo to Moonbase. The final thing I did here in the bottom terminal is actually upgrade the token. All I did was basically call the upgrade semi-native token function and passed in the same address of the semi-native token function here called isv2, and it was returning true. So we now know that the semi-native token proxy was now pointing to the new implementation, which is implementing that isv2 function. And yes, I apologize if the testing is a bit unclear here in the CLI, but you can see here that this was all working, and I'm happy to share the completed code here on the description of the video and take any questions if you guys have.
Well, I don't see any other questions in the chat at this point, Ben, and thank you so much for your presentation today. You know, I love seeing this stuff in action, and just to reiterate what you were saying earlier, when we're taking these tokens cross-chain, those tokens and the instructions are custodied the entire time by permissionless blockchains, each maintaining their own security. So, you know, I think that is in many ways the big breakthrough that we have here is we're not relying on centralized services at any point. We're relying on smart contracts and public blockchains. So amazing stuff. What's the best way, Ben, for people to get additional information? Do you have a way for them to reach out to you with questions or anything like that?
Great question. So we have a few different channels. Actually, for this, what we just showed in particular, we actually just released a 2-part blog also explaining what we just built. So I will share that with you, Phil, and we can leave this all in the description. But we have the blog. Absolutely. If you're interested in this tutorial in specific. We have our Axelar examples repository, which is how I learned all this stuff. So let me leave this here in the comments. Can I leave this in here in the comments? I'm not sure. I'll leave this with you here, Phil.
Yeah, that's fine. We'll make sure to. Yeah, we'll make sure to add it in here
Yeah.
to the description.
Yeah, the example shows you
Absolutely.
ITS integrations, but also just regular GMP integrations for sending just hello world messages between two chains and many other cool things that you can do with Axelar. We have a Discord page if any of you guys want to chat on there with the Axelar community. And if you ever run into any blockers, we have a support repository just specifically for questions if any of you guys ever get stuck. And I'll share that with you as well. So.
Absolutely. And to anybody who's starting development in blockchain, not sure where to begin or what to do first, reach out to us at Moralis, moralis.com/Discord, and you can get in touch with our team, other developers. We're happy to help you get going and get you going with the best tools in the business as well, provided by us and awesome partners like Axelar. Ben, on that note, I'll make sure that I get all of these links and everything added into the description. And we thank you so much for joining us today. Look forward to the next stream with you. Anything else you wanted to say to our group here before we close it out today?
No, that is it for me. If you're interested, check out. If you're interested in developing more, check out the links that we'll have on the video. Feel free to reach out to me anytime. And yeah, I'm excited to see what viewers will be building with this stuff.
Absolutely. Well, on behalf of Moralis and Axelar, have a wonderful day, and we'll see you in the next video.